everyone, and welcome to this Telit Cinterion webinar, Wi-Fi 6, Enabling Smarter Verticals in Digital Business. I am Amanda Slink, the head of global events here at Telit, and I will be moderating our event today. To explain this topic, I am pleased to be joined by Carmelo D'Agostino, our product manager at Telit Cinterion. Now, just before I hand it over to Carmelo to start our presentation, I do have just a few quick reminders for our audience. We will have time to answer some questions at the end of the presentation. You can simply submit a question by posting in the questions box, which is located near the bottom of your screen. Also, please take a second to check out the resources section for some additional information on our topic today. And finally, we will send out this replay link to all attendees at the conclusion of the webinar. So if you miss anything or want to go back over it, we'll be sure to get that link out to you. And with that, Carmelo, I will hand it over to you to start our presentation today.
Hello, Amanda, and welcome everybody to this webinar. As Amanda mentioned, I'm Carmelo D'Agostino, and I'm part of the product management team here in Telit Cinterion. Today, we are going to talk about Wi-Fi 6 and how this new standard can help enable digital business in order to make smarter verticals, helping connecting machines, material, people, process, products, and services, finally creating greater value for the end customer. Just before talking details about Wi-Fi 6, let me shortly introduce Telit Cinterion So IoT is all about making various things, for example, the device, that are in the field and they need to communicate with the application in the enterprise systems. This is what we call the first mile of the IoT. As you can see on this slide, the IoT value chain starts with the things in the fields and ends with the application that run in the enterprise systems. And it is made by three key segments: the edge, the network, and the cloud. At Telit Cinterion, we enable IoT solutions across these three segments with our expanded portfolio of products and services. Whether your business application is a home alarm panel, an energy meter, or a gateway for a substation in the energy grid, or a healthcare portable device, or a high-speed router, or a connect pallet that you need to track in a warehouse, or a wireless camera for surveillance, or anything as it comes to your mind, your first need is a wireless communication module to connect it to the internet. Telit Cinterion modules are not simple modems that transmit and receive data. They are reliable, feature-rich, intelligent modules that come with value-added software that allows, for example, the customer to run their own application inside the modules and then transmit the data to the server. Furthermore, Telit Cinterion modules are equipped with innovative device to cloud software agents, what we call One Edge and IoT connectivity activation, which, combined with their counterpart software on the server, enable out-of-the-box communication with the clouds. To connect your things to the cellular network, simple module is not enough, of course. You will also need cellular subscription. At Telit Cinterion, we offer global IoT MVNO data plans, what we call Next and Next Plus. And we can offer also a connectivity management platform. Alternatively, if you prefer, we can enable for you the activation of third-party cellular connectivity with state-of-the-art bootstrap technology and smart connectivity subscription provisioning. Of course, cellular connectivity modules can be connected and combined in different ways, leveraging embedded SIM technologies such as UICC or IUICC and SIMWISE. For what concerns the cloud domain, Telit Cinterion offer provides Essent One Edge device management for small things like, for example, resource-constrained and battery-operated devices that needs to be monitored and operated remotely with the minimum possible consumption of data and power. At the same time, Telit Cinterion offers also device-wise IoT platform for bigger industrial machine that basically have a focus on IT or OT integration for the industry 4.0. We can also offer trusted identity management for secure authentication during the entire lifetime of the device. Furthermore, One Edge can also be used by the customer as a data orchestration middleware platform to efficiently transport data between the things at the edge and the enterprise system in the cloud. And ultimately, the data must be transferred to the customer enterprise systems that maybe you already have in place. And as it's quite common right now, it's in some well-known hyperscale cloud platform like Microsoft Azure or Amazon AWS. Lastly, with the recent acquisition of MobiLogix, Telit Cinterion has the advantage of offering turnkey IT solution tailored to a customer needs from the idea to realization and to the final product. This service is basically targeting those customers who either do not have the resources to do a complete custom IT project in-house or simply don't want to move R&D resources or critical resources away from their core business. To conclude on this slide, I would like to stress that all these Telit Cinterion products and services that I've just described briefly here, they all incorporate an E2E approach to cybersecurity, extending from the edge to the network and all the way up to the cloud. Now, let's talk a little bit more in detail about Wi-Fi. That is the main topic of this webinar. Today, as we all know, Wi-Fi is a household name, synonymous with delivering high-capacity wireless services that are used to support the vast majority of smartphone data usage. This cost-effective technology, coupled with an open ecosystem, together with ease of upgrades that ensure backward compatibility with all the already deployed Wi-Fi devices, has created the astonishingly successful market. You can imagine that just last year we recorded deployment of over 3 billion new Wi-Fi devices. However, the Wi-Fi Association and Wi-Fi industry isn't resting on its laurels. The latest announced Wi-Fi 6 standard that has been recently introduced, it's not just the next generation Wi-Fi, and it's just increase in terms of better throughput and coverage, and that will improve all existing deployment. Furthermore, it basically determines the basics for new capabilities that can be used by the industry to address a whole new set of opportunities, as we are going to see. Talking a little bit briefly about the high story of Wi-Fi technology, that basically has existed since the late 90s. I think in a couple of years ago, in 2019, the Wi-Fi Alliance has marked its 20th anniversary. And during all these years, the technology has improved dramatically, and we are going to see how. As I was mentioning in my previous slides, Wi-Fi 6 is a substantial upgrade over previous generation, although the difference may not seem so obvious to the average user. Speed, for sure, is the most notable characteristic, as we can see here on the table. Wi-Fi 6 supports a theoretical maximum output of 9.6 gigabit across all multiple channels. This is quite an uplift over the around 6.9 gigabit offered by Wi-Fi 5. But we should not forget that this capacity is shared across all the connected devices, and Wi-Fi 6, as we are going to see, can support more devices than the older Wi-Fi 5 standard. Wi-Fi 6 also offers improved latency, handling network traffic more efficiently, and we are going to talk more in details about this in the next slides. Finally, Wi-Fi 6 has adopted the orthogonally frequency division multiplexes access, or in short OFDMA, which provides support for high density deployments, enabling more efficient allocation of bandwidth to multiple users simultaneously. This will also help to reduce power consumption on devices, ensuring that they receive high quality connectivity without regularly searching for the required bandwidth. With this slide that I'm showing here, I would like to highlight a few new technical features that have been introduced by Wi-Fi 6. And these are either new feature or feature that were already present in the previous version of the standard but have been greatly improved. So we have to keep in mind that Wi-Fi 6 main goal is to attack or to solve the main issues that we had in the past release of the standard. Performance and the support for the increased density of devices with different applications that are running simultaneously. So this new standard implements several features that altogether help to achieve all this. First of all, I would like to talk about the BSS coloring, or basic service set coloring. These allow to assign, let's say, a color to data from each Wi-Fi access point, so that the network can differentiate between Wi-Fi network operating in overlapping frequencies. In other words, BSS coloring allows network to identify who is transmitting, so that they can mitigate collision between signals from nearby networks, resulting basically in overall better network performance. We can think this that can be really useful, for example, in venues such as retail malls, multi-dwelling units, and such as. The next feature that I would like to mention is the orthogonal frequency division multiple access, or in short OFDMA. This technology, OFDMA, is the multi-user version of the orthogonal frequency division multiplexing modulation that was used by previous version of the Wi-Fi standard. Wi-Fi 6 standards basically used the OFDMA for increased efficiency. If we want to visualize what this feature is, we can imagine our Wi-Fi connection as a series of delivery tracks delivering data packet to our devices. With previous version of the standard, each delivery track or packet could only deliver one parcel to one device at a time. Now, with OFDMA, each track can deliver multiple parcels to multiple devices simultaneously. This vast improvement in efficiency work for both uploads and downloads. In other words, OFDMA improves Wi-Fi performance, particularly in high-density, high-throughput environments, such as in, in a stadium or an auditorium. We can talk now about the 1024 QAM implemented by Wi-Fi 6. This is a faster modulation scheme that packs more data. With the 1024 QAM, each symbol indeed carries 10 bits rather than 8 bits. Practically, this modulation helps to increase the throughput in Wi-Fi network by encoding more data in the same amount of spectrum, improving raw speeds by around 25% compared to all the modulation schemes. This is very helpful to support, for example, use cases such as ultra definition video, augmented reality, virtual reality, or other next generation of learning, remote learning, or e-classrooms. Now, if we think about IoT low power or constrained user case, uh, basically on the other range of the spectrum, again, Wi-Fi 6 technology is the right solution. Indeed, Wi-Fi 6 introduced the target wake time, or TWT, um, that improves the battery life by increasing the device sleep time, so that the device can spend more time in sleep mode, conserving battery. This feature is very focused for constrained IoT devices. Another interesting feature is the MU-MIMO, or MU-MIMO, standing for multiple user, multiple input, multiple output. Wi-Fi 6 is capable of simultaneously maintaining 8 streams of data. 8 by 8 MU-MIMO potentially double the data rate compared to the previous generation of the 4 by 4 multiple user MIMO access point. Indeed, if we think with traditional multiple user MIMO, multiple user could access the router at the same time without any noticeable decrease in the bandwidth quality, but for sure up to a certain point. Now, with the 8 by 8 multiple user MIMO, more than 8 streams are available for user to choose from. And whereas in the Wi-Fi 4, these worked only for downloads, with Wi-Fi 6, we can have 8 by 8 multiple MIMOs for uploads and for downloads. This is a significant capacity boost and address the use case from enterprise network, large public venues, and multiple dwelling buildings. The last but not least point that I would like to mention in this short technical Wi-Fi introduction is security. As we know, security is becoming more and more critical in our network infrastructure. This is why, and this is the reason why all Wi-Fi 6 devices support WPA3 personal. It will be also possible to implement WP3 Enterprise for an added extra layer of security. After this short introduction from the technical point of view, let's go more practical and let's see some real case application where Wi-Fi technology can bring real business benefits. Let's see what Wi-Fi 6 can bring to the healthcare vertical and ecosystem. This is quite important because according to several studies, the healthcare market is projected to reach, and as indeed has reached more than 108 billion US dollar in the past year, so in 2022, and it is anticipated to grow at a rate of around 18% in the next years, reaching around $950 billion by 2032. So this is, you can imagine how important this vertical is for the economy. So Wi-Fi 6 improved the device density and energy efficiency that I was mentioning earlier, are indeed ideal for supporting a wide range of IoT medical devices. These devices can include wearable sensors, remote monitoring equipment, smart medical instruments, medical management system. In all these cases, Wi-Fi 6 ensures reliable connectivity, efficient data transmission, and longer battery life for these devices, improving patient care and enhancing the efficiency of the healthcare operation. Furthermore, Wi-Fi 6 faster speed increased capacity and lower latency enable high-quality video conferencing for virtual consultation, monitor patients' vital signs remotely, and provide real-time guidance. You can see how this could be very impactful for people or patients that lives in remote area or that have very limited mobility. Finally, the low latency provided by Wi-Fi 6 can enable more and more forward-looking applications in the healthcare, like medical procedure using a remote-controlled robot. So, by leveraging Wi-Fi 6 in the healthcare settings, hospital and healthcare facilities can improve efficiency, enhance patient care, enable remote services, and facilitate the seamless exchange of critical information, ultimately leading to a better healthcare outcome. Let's move to another space, so telematics. The Wi-Fi use case in this space are plenty, and for sure I can imagine that Wi-Fi 6 feature, new introduced feature, will enable even more. For example, we mentioned earlier that Wi-Fi 6 introduced the techniques to reduce latency, or basically the delay in data transmission, resulting in faster response times. This is crucial for telematic applications that require real-time data processing. Let's think about vehicle-to-vehicle communication, or we can think about collision avoidance systems, and finally, autonomous driving. Low latency that is can be provided by Wi-Fi 6 features ensure quick and accurate decision making, enhancing the safety and the efficiency of telematic systems. Improved outdoor performance enabled by Wi-Fi deployments to better serve connected care use cases allow Wi-Fi to offload the delivery of the firmware, mm, what we call firmware over the air, FOTA, from the cellular network to the Wi-Fi network. If we think what is inside the car, where right now the cable represents 60% of the mass of the vehicle, so this is very, very more than half of the weight of the vehicle of the car is made by cables. The use of Wi-Fi to connect, for example, different electronic controller that are spread all around the car could have a great impact on fuel efficiency, because for sure we can make our car less heavy. Speaking more technical feature introduced by Wi-Fi 6, like the increased guard intervals and mid-ambles that are defined the 11AX standard, enhance the ability to support two payment and ticketing services, uh, basically enabling vehicles traveling faster through automatic barriers, and so allowing quicker traffic flows. Finally, Wi-Fi 6 incorporated the latest security features, such as the WPA3, that provided stronger encryption and authentication mechanism. In telematics, where the exchange of sensitive data occur between the vehicles and the external system, robust security is crucial to protect against unauthorized access and eventually potential cyber threats. So, to conclude on this slide, uh, by leveraging the advantage of Wi-Fi 6, a telematic system can provide a faster, more reliable, and secure connectivity between vehicles, infrastructure, and the broader ecosystem. These could facilitate advanced features like real-time navigation, vehicle-to-vehicle communication, fleet management, and telematic analytics, ultimately enhancing driver experience, safety, and overall efficiency in the transportation. Let's move to another vertical, such as the retail and the entertainment. As I was mentioning a few slides ago, Wi-Fi 6 introduced a feature that is called target wake time that basically allows device to optimize power usage by scheduling the wake time and sleep periods. Uh, Retailers could leverage this feature to implement more accurate and efficiency location-based services. Let's take an example. They could provide personalized offers, promotion, and recommendation based on a customer location within the store, so that this will enhance the marketing effort and improve the customer shopping experience in the end. Wi-Fi 6 improved device density and higher data transfer rates enable more comprehensive and accurate collection of customer data so that retailers could use this data to analyze foot traffic patterns, dwell times, and then customer behavior within the store itself. Such insight help optimize store layout, product placement, and staffing levels, so that ultimately the operation efficiency of and customer satisfaction of the store can be improved. Now, if you think about entertainment, Wi-Fi 6 low latency and increased bandwidth are particularly advantages for virtual reality and reality application. It enables more immersive and responsive experience by reducing the delay between the user action and the system response. Whether it is gaming, virtual tours, or interactive experience, Wi-Fi 6 ensure a high quality and immersive environment for virtual reality and augmented reality entertainment. If we think about bigger spaces, like, I don't know, stadium, concert halls, convention center, again, Wi-Fi 6 increased the capacity and improved the device density are really advantageous for supporting a larger number of connected devices. We can think that it could enable attendee to access event apps, engage in social media interaction, and stream live content without network congestions. Let's talk about what will be the Wi-Fi 6 advantage for industrial IoT. Um, so I mentioned that Wi-Fi 6 improve on determinism, low latency, longer range, and high throughput. And this will be uh, necessary to facilitate and support Wi-Fi based industrial automation. I could list several scenarios where modern industry or industry 4.0 as it's now called could benefit from Wi-Fi 6 technical advancements. I would like to focus on three simple examples for the sake of time. First, think about industrial control system that require more and more high throughput and low latency wireless communication capabilities. Second, as we have seen, Wi-Fi 6 offer lower latency and increased determinism. This will definitely improve control and management of augmented guided vehicle (AGV) without the industrial environment, as we have seen for the telematics systems. Finally, battery-operated devices such as sensor that generally require low power consumption can really use the target wake time feature offered by the Wi-Fi 6 technology in order to save battery and stay alive for longer time. Uh, what's more, as we all know, the number and the density of IoT device is increasing dramatically in the industry, and we need technology like Wi-Fi 6 that are able to support a higher number of simultaneous connection while avoiding interference due to the cross coverage. By using all these features that I was mentioning earlier, like the OFDMA, the multiple MIMO, the target wait time, the BSS coloring, and spatial reuse techniques, Wi-Fi 6 offers an excellent performance and resistance to interference, even when the density of device becomes high, like in industrial space. Let's see one last vertical where I think that Wi-Fi 6 will have a big impact. So let's talk about smart cities. As we have seen, Wi-Fi 6 enables significantly faster throughput in high-density environment where many devices must use the same wireless access point. And this is the case in smart cities. And indeed, one of the reasons for this new standard, or one of the goals of the Wi-Fi 6 standard, is to increase the network performance in high-density network. When equipped with Wi-Fi 6, real-time traffic monitoring system can use artificial intelligence algorithm to perform advanced video analytics and, in response to live or current condition, control signals, lights, and lane opening in order to optimize throughput and minimize the traffic delay. Behind the highway, the real-time responsiveness and the ability to connect many devices will let Wi-Fi enhance pedestrian and area and bike path tools. For example, we can imagine a lamppost that can turn on and off as needed when people are present. Or at the same time, we can have a sensor that are spread around the city and can send real-time alert to warn everyone of oncoming traffic or pedestrian crossing, etc. Geofencing that basically is a way to monitor activity within a preset geographical boundary can be used to manage more precisely water and energy according to real-time events, like, for example, a sudden change in the weather or a public gathering. Within the city infrastructure, the high-density capability integrated into the 11AX Wi-Fi 6 standard with the help of the 5G cellular technology will enhance essential services such as the utility grid and the waste management. To conclude, by leveraging the advantages of Wi-Fi 6, smart cities can build a robust and reliable connectivity ecosystem, facilitating efficient data exchange, improved urban services, and enhanced the quality of life for residents. Now, we have seen several use cases that, thanks to the Wi-Fi 6 or Wi-Fi 800.11ax standard, with all these technical feature that this new standard introduced, brings benefit to the final user. But what about the advantage for the service provider? Here, indeed, when deciding on the future strategy for delivering the next generation of wireless services, service providers need to consider a variety of issues. Just to list a few, for example, the size of the ecosystem, the compatibility with existing network and devices that they have already in their they already provide. If they can reuse the management platform that have been already deployed. If the wireless services that they are going to deploy is scalable and can be used by a bigger, higher number of devices. If the service the provider also to consider the spectrum availability and regulations, and for sure the cost of the equipment. In my opinion, Wi-Fi 6, with the Wi-Fi 6, the Wi-Fi is a technology that is well positioned to address all these critical aspects. And in my opinion, with Wi-Fi 6, all these Wi-Fi 6 features can be bundled with 5G technology in order to deliver, let's say, a 5G cellular use case in a very cost-efficient manner. Indeed, uh, talking about Wi-Fi, perhaps the greatest factor in the success of this technology is the effectiveness of the economic investment. Retailers, manufacturers, services industries, transportation, and communities around the world have recognized the basic value, economic value that you can realize with Wi-Fi solution. Uh, I would like to briefly list three drivers of this high return on investment, or they call it the ROI of Wi-Fi technology. First of all, I would like to mention the low cost of deployment. Access point devices, as we call them access point AP, are available with a wide range of prices and features, from the low-cost devices that we can find in our home, around that cost around $30, to enterprise class devices that can be optimized and customized for every application that could cost thousands of dollars. Second, the user value for ubiquitous access. As we, as we all know, customer finds value in wireless access to the internet. We are so used to it that sometimes we change our shops, our line, cable operator, just because of the quality and the quantity of the internet access. And many retailers have successfully translated this customer value into increased sales by simply showing signs that says free Wi-Fi services. So uh, these public services have become so ubiquitous that in our society that we are now surprised not to find I mean, we'll be surprised to find a coffee shop, a restaurant, a shopping mall, or airport, or an hotel, I don't know, whatever, that doesn't not offer free Wi-Fi. Third, the last point that I think it's quite peculiar to Wi-Fi technology is its economic model that is based on services rather than access. So if we compare cellular technology versus Wi-Fi technology, we can see that almost $0 of the economic value of the Wi-Fi is is based on paid access to the Wi-Fi, the network. In other words, access to the Wi-Fi is free because the economic model is based on the value of the services provided rather than the access itself. So this is a vital and key differentiation over cellular services economics, which are all about user paying for accessing the cost and the spectrum. Okay. So to conclude this webinar, I would like to talk a little bit about Telit module portfolio. And as I was mentioning at the beginning, Telit Cinterion commercialized solution supporting cellular IoT, LPWAN, LTE, 2G modules, cellular broadband such as LTE and 5G module, positioning module, and short-range Wi-Fi modules. In particular, if we want to talk about short-range Wi-Fi modules, the portfolio is quite large. We have modules that support Wi-Fi 4, single band, like the W310F5, or dual band technology, like the W310G4. These modules are also support also Bluetooth 5 technology. Going up in performance, we have also modules such as the WE866C6 that is compliant with the Wi-Fi 5 standard. It is a dual band module, so it supports 2.4 and 5 gigahertz. And what we consider peculiar of this module that is an excellent companion for our LTE cellular modules. And again, also these modules support Bluetooth Classic and BLA standards. And finally, we have an upcoming new Wi-Fi module, the WE310K6 modules, and this will be a dual band, dual stream Wi-Fi Bluetooth 5.2 modules. All these modules are based on surface mount technology that enhance their robustness, and the LGA package ensure that they can be easily embedded into your size constrained application. These, coupled with their extended operating temperature range, there are all industrial temperature range, enable our modules to meet Wi-Fi and Bluetooth design requirements that could be needed in the industrial space. So with this, I think that I've concluded my presentation. I hope that this was interesting for you, and I give it back the screen to and the control to Amanda. Thank you, everybody.
Yep, thanks, Carmelo. Just before we get to questions, audience, I am going to drop a poll on your screen here. If you'd like to have somebody contact you directly, please just respond here on the poll and we'll be sure to connect you with someone. We do have time for just a few questions here in the time that we've got left. So Carmelo, I will just dive right in. The first question that we received, in this presentation, you talk a lot about Wi-Fi 6. Can you explain what the main difference is with Wi-Fi 6E?
Yeah, thank you. This is an excellent question. Indeed, I didn't talk a lot about Wi-Fi 6E in my slide because Wi-Fi 6E is basically similar to Wi-Fi 6 from what concerns the technical feature that it introduced, but with an addition of an E that stands for extended. Wi-Fi 6E is extended since this standard defines the use also of the 6 GHz band. So simply to simplify and to summarize, Wi-Fi 6E means Wi-Fi 6 extended to the 6 GHz band. 6 GHz is a new frequency band that allows additional spectrum. Accessing the 6 GHz frequency brings more bandwidth, faster speed, and lower latency, opening resources for either more future innovation like other augmented reality, virtual reality, 8K streaming, and even more. Okay, so this is the main difference between the two technologies.
Great, thank you. Next question I have, do you think that Wi-Fi 6 can replace 5G cellular installation?
Oh, yeah. I mentioned the 5G during my 5G cellular during my presentation. I think this is something that I would like to explain a little bit better. So thank you for the question. So we have seen several cases where Wi-Fi 6 can bring important benefits. However, I would like to stress it's not enough for all kinds of applications. For example, if we think of applications that require high mobility or application that needs very long range communication, for example, we can see of an outdoor IP camera where they